Okay, welcome to another video. What we're going to be looking at today is the discriminant, which builds on what we looked at in the last video, which you might remember was the quadratic formula. So just to recap, the quadratic formula says that if we've got a quadratic equation, ax squared plus bx plus c equals 0, then we can get solutions to the equation using the quadratic formula, which says that x equals negative b plus or minus the square root of b squared take 4ac all divided by 2a. So this is kind of a shortcut for getting the solutions or the roots or the x-intercepts when a, b and c are too complicated to factorize the quadratic. What I want to do first of all is just look at a few things that can happen when we're using this formula, and that'll sort of lead into this idea of the discriminant. So first of all, let's just consider our example from the last video. So don't worry about writing this down yet unless you really want to. This is just to sort of illustrate what the discriminant means. But last video we did an example and we said negative 5 plus or minus the square root of 9 over 2. Oh, and I apologize, that's not y, obviously, that should be x. So we were solving an equation using the quadratic formula, and we said x equals negative 5 plus or minus square root of 9 over 2. And based on that, we eventually got to two different solutions. Now, why do we get two different solutions? The reason for that is that we have this symbol here, the plus or minus symbol. So that means that when we're evaluating this, we have to consider the case where we've got negative 5 plus the square root of 9, and also the case where we've got negative 5 take the square root of 9. So that gave us two solutions. Okay, I just want to consider a hypothetical example. What if x equaled negative 5 plus or minus the square root of negative 9 over 2? Well, in that case, things get a little bit tricky because we've got a negative number under a square root sign. And you might remember that if that is the case, then we can't get any real solutions. We can get imaginary solutions, which is a concept for another day, but we can't get real solutions. If you put that into your calculator, you would get an error. So if that number there is negative, well, we can't get any real solutions. There's no point going any further. And let's consider just one more possibility. What if I'd been using my quadratic formula and instead of a 9, I got a 0? Well, in this case, suddenly the plus minus sign doesn't mean anything anymore. That's irrelevant because the square root of 0 is 0, so we can just cross that part of the equation out. And if we were doing this, then our answer would just be negative 5 over 2. So in this case, there was one solution. And as it turns out, this number under the square root sign in each of these cases has determined how many solutions we got. So when it was positive, we got two solutions. When it was negative, we got no real solutions. And when it was 0, we got one solution. And as it turns out, that's what the discriminant is really all about. The discriminant is just that number underneath the square root sign. So here's the part that I want you to actually write into your book. The discriminant, which we refer to with the Greek letter delta, which is just like a little triangle, is equal to b squared minus 4ac. In other words, it's equal to this bit here in the quadratic formula. So that's the discriminant, and we say that if the discriminant is greater than 0, there are two distinct real solutions. If the discriminant equals 0, there is one real solution. And you might hear that referred to sometimes as a repeated solution or a repeated root, because normally we expect there to be two, and if there's one, we just say that it's the same one twice. It's repeated. So that's why you might see that. You might also, the third case is that the discriminant is less than 0, and that means that there are no real solutions. So the discriminant's really handy because without doing the entire quadratic formula, we can use it to figure out how many solutions we're going to get. One more thing, if the discriminant is a square number, e.g. 1, 4, 9, 16, etc., then we know that the solutions are rational. But more importantly, we know that the equation can be factorized. And the equation can be factorized. So that's kind of handy as well. If you're looking at a quadratic equation and you're like, I'm sure I can factorize this, but I can't quite get it, what you can do is work out the discriminant, and if that is a square number, then you know that you should be able to factorize it. Okay? All right, I want to do an example now. So let's have a look at a quadratic equation. For example, 2x squared, take 2x plus 3 equals 0. If we have a look at this equation, we can say, here's A equals 2, here's B, that's negative 2, and here's C, that's 3. Let's work out the discriminant for this equation. So the discriminant is b squared minus 4ac. B squared is going to be negative 2 in brackets squared. Remember, we always have to put that in brackets. And then 4 times by 2 times by 3. So negative 2 in brackets squared is going to be 4. 4 times 2 times 3 is 8 times 3, which is 24. And 4 take 24 is negative 20. Since that's a negative number, then we know that there are no real solutions. So there's no point continuing with this one. Straight away from working out the discriminant, we know that we've got no real solutions. Okay, let's look at something a little bit trickier. So for this next example, I'm going to do something slightly more complicated using algebra. So I'm going to say I've got a quadratic equation which says that x squared, take 2x plus m equals 0. And we don't know what m is. M is just some number, okay? And what we're interested in is when will m give us 2 solutions, when will it give us 1 solutions, and when's it going to give us no solutions. So we're interested in how does m affect the discriminant. And this example is actually on a little handout that I'm going to give you in class as well. So if you need to refer back to it, then you can. So let's look at this first off and pick out a, b, and c. So since x squared is just by itself, we know that A equals 1, because there's a 1 out the front, we just can't see it. B equals -2, and M is what we're going to use for C. So let's write down our expression for the discriminant. The discriminant is b squared minus 4ac, which is -2 again, in brackets squared, minus 4 times 1 times m. So if I work that out, that comes out to 4. Take 4m. So obviously, depending on what value m takes, that's going to affect the number of solutions or the number of roots. Okay, first of all, let's say for a repeated root or one solution, the discriminant has to equal 0. So that means that 4 take 4m equals 0. If we rearrange that, we can say that 4m equals 4. If these two numbers subtracted equal 0, they must be equal to each other. And so m must equal 1 if we divide both sides by 4. So if we want to get one solution, m has to equal 1. Let's look at the next case, because this is a bit trickier. What about if we want two solutions? Well, in that case, we know that the discriminant has to be greater than 0. So 4 take 4m also has to be greater than 0. In other words, now I just need to be a bit careful here with my greater than sign, because it sort of works like an equal sign, but not quite. And I'll show you why. First of all, what I'm going to do is take the 4 over to the other side. So I've got -4m is greater than -4. Now what I'm going to do is divide by -4. But if I'm using an inequality, like a greater than sign, if I ever multiply or divide by a negative number, I have to switch the way that sign is pointing. So what this now becomes is m less than 1. So I've divided both sides by -4, which makes that switch. Okay? So m less than 1 will give us two solutions. And we'll look at the final case now. If we've got no real solutions, you can probably guess what the answer is actually, but the discriminant is going to be less than 0. So 4 take 4m is less than 0. I'm sort of following the same process now. -4m is less than -4. Now I need to do the same thing and divide by -4. That's going to switch the direction of that sign as well. So that's going to become m greater than 1. So if I look at this problem, I know that if for the discriminant to be 0, to give me one solution, m has to equal 1. For there to be two solutions, m has to be less than 1. And for no real solutions, m has to be greater than 1. So that's one of the other handy little things that we can do using the discriminant. Okay, thanks for watching.